the delta S is positive. Delta S is disorder. Nature does have a tendency to try to become more disordered, like the example of the throwing the cards in the air. We throw the cards in the air. Naturally, the cards are going to be messy when they land. It's going to make a big mess. That's what nature tends to do. Things tend to become more messy. So in a reaction, a positive delta S is the tendency of nature. A negative delta H, to give off heat, is the tendency of nature. So when you have a reaction that has a positive delta H, that's not a favorable condition for it. We're going to talk more, I think, even in the next slide about that very thing. But for right now, let's just take, if you will, if you don't mind, grab a calculator, or somebody at least grab a calculator. We don't all have to do this calculation because it's simple. But let's find the delta G of this reaction at negative 10 degrees Celsius. So we're trying to melt ice at negative 10 degrees Celsius. What would the delta G value be? Let's take a look. It's delta H, which is 1633, minus T, which is negative 10. Always have to have our temperatures in Kelvin. So it's 263. Kelvin, times the delta S, which is positive 22.1. Can you crank that number out? The units are going to be just joules per mole at the end. Delta G equals, in this one,
221.
Positive or negative? It's positive 221. And I'm just going to go to the whole number, joules per mole. Thank you. Positive delta G means what?
Not spontaneous.
It's not going to happen spontaneously. Like we talked about yesterday. If we walk into a walk-in cooler and it has a temperature of negative 10 in there, we have a jar of ice. That jar of ice is just going to sit there, assuming it's not getting heated from our hand. We set the jar down. That ice won't melt. It doesn't. This is not happening spontaneously at that temperature. Now, let's do the same calculation down here. We're going to skip the 0 degrees for a moment and come down here to 10 degrees. Let's do the same thing. Delta G of this condition is 6033. I'll just do the numbers. Minus T, which is 283 now in Kelvin, times 22.1.
Is this for
The positive 10 degrees. What do you get for delta G?
negative 221?
Negative 221. Right. Oh, jeez. Negative 221 joules per mole. So at this temperature, this process is spontaneous. If we're walking into a cooler, but the temperature in there is positive 10, set our ice down, we would see, it's a very long, slow process, as you know, but the ice would start to melt. It happens spontaneously. I mentioned this yesterday, I'll say it again. Spontaneous does not necessarily mean fast. Don't try to equate those in your brain, okay? Spontaneous means it's going to happen, but it might take a long time for it to happen.
How long is it going?
Could be years. That's a ridiculously slow thing, but it's possible. Yeah. Yeah.
So as you're saying, if it's not spontaneous, it's not possible at all.
Right. One of the examples that I have cut out because I'm kind of short on time in this chapter, but we could calculate the delta G of diamond changing to graphite. It's negative. Diamond changing to graphite has a negative delta G. Yeah.
Like thousands of
Yeah,
years?
exactly. Even thousands of years probably is not enough. I mean, yeah, so diamond will spontaneously change into graphite.
Will something spontaneously change in time?
No. You have to do work on carbon to get it to change to diamond. So, yeah, well, you know, there's this saying that diamonds are forever. They were wrong. It's not true. Anyway, so yeah, the sign on delta G is extremely important. That was why I was such a buster on the reading quiz. And if you had the wrong sign on your delta G, then you got marked wrong. I guess it wasn't such a big. Yeah, I guess everybody had a negative delta S. You didn't. You calculated delta S on the reading quiz, not delta G, but still, the sign on delta S is very important too.
Reading quiz we did.
Yeah. No, I didn't mean that. Okay, so you can see what's happening here. The delta G at negative 10 degrees is positive 221. At positive 10 degrees, it's negative 221. What do you think the delta G is at 0 degrees?
0.
Right. So the delta G at this temperature, we're not going to bother calculating. In fact, I don't like having you calculate because when you calculate this out, you don't get 0. You get something very close to 0. Did you calculate it? What'd you get?
0.3.
0.3?
Yeah.
Or negative 0.3?
Negative 0.3.
Well, when you look at negative 0.3, you say, well, it's spontaneous to go that way because it's negative. But the point is this. These two are estimated numbers. They're rounded off. And if we were able to calculate and everything was perfect, we would get exactly 0 for delta G at 0 degrees. Now, what does it mean if delta G is 0?
There's no reaction. Nothing happens.
Mm-hmm.
Equilibrium.
Yeah, that's exactly what it means. If you have a negative delta G like we had at 10 degrees, that means the reaction is spontaneous in the direction to the right. If you have a non-spontaneous, like at negative 10 degrees, that's non-spontaneous because the delta G is positive, that means it is spontaneous in the opposite direction. That means if we walk into this cooler and we have a glass of ice and we wait long enough, it'll freeze spontaneously because this direction is spontaneous. You with me? At 0 degrees, where that phase change happens, that is at at equilibrium. I want you to picture this. Imagine that we have a walk-in cooler. We all walk into it, and that cooler is set to 0 degrees. We have a glass of water, and we take the glass of water and set it down. The glass of water maybe starts at room temperature, gets in here. The environment is 0 degrees. That glass of water is going to cool from whatever temperature it was down to 0. As soon as that glass of water hits 0 degrees, now it's the same temperature as the surroundings. Does it freeze?
No.
No. It doesn't freeze. If you have a jar of ice, the ice has to be frozen at something less than 0 degrees. Bring the jar of ice into the walk-in cooler at 0 degrees. Set it down. The ice, whatever temperature it was, is going to rise to 0. Will it melt? No. That's a weird concept, isn't it? Strange. But you need, because as soon as that ice hits 0 degrees, now there's no longer any exchange of heat. It's now in thermal equilibrium with the surroundings, and so it doesn't melt. Yes?
So, what about like when is it possible for not all of it to melt or not all of it for freeze? You know what I mean?
If the temperature is exactly 0, then none of it will, like if we start with ice, none of it will melt.
Have you ever had like a water bottle on a cold car and so there's some ice but there's not a lot of ice? Like there's like ice in the middle of the water?
Yes. There's more going on than just the freezing process, though, in that. There's a lot of factors, yeah. We're assuming all the other factors are negligible. Yeah. Amber?
But if you have a cup of water of room temperature and you put it in an environment of 0 degrees, wouldn't it give off some heat to the environment?
Yes.
So,
So the environment will warm up, right?
so it would end up being like 1 degrees or something.
Yeah, so there is always that exchange of energy. Yeah, when you put something warm into something cold and they have contact with each other, the warm thing is going to cool off, like the water would cool off. Would the surroundings rise up? Yeah. So if we're in this cooler, the cooler's got a motor on it that's trying to keep the environment right at 0 degrees. And so, yeah, you're right. There is an exchange of energy. That warm water in the cooler is warming the cooler up. But the freezer, we assume, is recirculating, the 0 degree, so that I guess makes it you got kind of an external factor in that case. Yep. Okay, so here's the point. If delta G equals 0, the system is at equilibrium. Nothing is going to happen. It's not going to go to the right. It's not going to go to the left. It doesn't do anything.
Sure.
Yeah.
How come boiling water cools faster than
Newton's law of cooling. Ask a physics person. I don't know why. That's a strange idea. Yeah. Yeah. Yeah, it's the kinetic energy. I'm not really sure.
Oh, yes, I do.
It is true. Weird.
I'll periodically do like a lot of people fully.
All right. So anyway, we get now to this. This idea, man, you'll see. I would venture to say that there would be a question about this, the sign on delta H and delta S, and what it does to delta G, on the AP exam in May that you take. You're going to see this in the end of the chapter problems. You're going to see this on the practice test. I guarantee this idea is going to be on the real test. I guarantee it. This just shows up everywhere in chemistry. You take a college chemistry class, you're going to do this kind of thing. I'll just be quiet for a second and let you copy that down, and then we'll talk about why it is like this. You have to know this slide.
What's that? Like, you know, it always says you're like delta G and then there's like a isn't that just
Yeah, we're going to talk about that. You'll finally get a good answer to that. I hope.
Because it's just been there and I was like,
Yeah. And you see it in the book too. I'll explain it today. I hope.
I hope.
I will.
Wow.
Yeah, we only have one day left after today, so I'm not
How are we gonna
going to get through all of it.
What Tuesday?
Tuesday's our quiz.
Wait, hello?
So there won't be a lab in this chapter. Yeah, unfortunately, Monday is going to be a lecture day. I'm going to have to take some time on Monday.
Wait, so this is more. Is it true it has to be negative 40 degrees for a cold day?
Yeah.
Negative 40 with wind chill.
Negative 20. Wind chill.
Really?
Yeah.
Last 20 is negative 40.
No,
That's pretty cold.
not in here.
There's this like thingy on my desk.
Well, don't scratch yourself on it. Okay, now this is what I'm describing. I am going to get to that degree sign before too long, but in terms of the idea of favorable and non-favorable, it's favorable for nature to have a negative delta H. That means it's giving off heat. Nature tends to want to do that. It's favorable for a reaction to have a positive delta S. Things tend to become messy. So when you have a favorable delta H and delta S for a reaction, then you're definitely, no matter what the temperature is, going to have a spontaneous reaction. Think about it mathematically. If you have a negative number here, and you're subtracting a positive number here, because T is Kelvin, that's always positive, and delta S is positive too. So a negative minus a positive number will always give you a negative value for delta G. No matter what that T is big or small, it doesn't matter. Negative minus positive is always going to be negative. Now, in this case, delta H is favorable. Delta S in this case is negative, it's not favorable. Okay, let's see. So if I have a negative number minus a negative number,
Then it's a positive. Or it could be. It's like negative plus a positive.
yeah, you're adding this term, aren't you?
Oh, so that's why temperature.
Okay, so that's why the temperature matters, because if we want delta G to be negative, that's when a reaction is going to be spontaneous, only if delta G is negative. This term has to be small, and